Python is one of the world's most popular programming languages with over 8 million developers. This language has completely taken over the programming world, and for one very good reason. It's super easy to get started with, even if you've never written a single line of code before. What's even more exciting is that Python is everywhere, from web development and automation to data science and machine learning. Now let's talk about why it's so important to start with projects, especially if you're just beginning your journey in Python. I get it, you're just starting, it's very tempting to just stick with tutorials and practice exercises on anything that revolves around the very basics. But here's the thing, projects are where the real learning happens. When you dive into a project, you're not just following along, you're making decisions, fixing bugs, and figuring things out on your own. And that's what actually makes you a better programmer and also helps you stand out. So in this video, we will be building 5 Python projects. They're designed to help you get started without diving into any complexity. We're talking fun, beginner-friendly stuff like a number guessing game and a dice roller, perfect to get you comfortable with basic logic and randomization. But as you move through these projects, you'll be leveling up. We'll go from these simple games to more intermediate challenges like a screen recorder where you learn to work with external libraries like OpenCV and PyAutoGUI. And then we step it up with a round-robin scheduler, a project that introduces more advanced concepts. And to top it all off, you'll build a complete to-do application. This is when things get really exciting. This is when you'll be working with a project that's not just functional but also practical. So these projects are going to function as the stepping stones that take you from a beginner to a confident coder. So without wasting any time, let's get started. So let's get started with our first code, which is a dice roll game. So first let's see the working. So once I run the code, the first output is number 3 over here. As you can see, this is a dice format and it's giving the output as 3. And the next prompt is roll a die question mark and it's asking us yes or no, right? So if I give yes, there it's given another random number which is 2. First it was 3, then it's 2. Let's see if I give a yes again. So it's 3 again. So let me do it a few times and see how it goes. And it's giving random numbers, right, in the format of a die. But what if I give a random input, say F? So it's giving me an invalid character. So if I give no, it's going to terminate the game and it's giving thanks for playing as an output. So this is a very simple code and it is very easy to build. So let us go to our Visual Studio and create a new file. We'll call it dieroll.py and let's get started. So first let's look at the basic intent of our code, right? So our first prompt is going to be roll a die question mark, right? And if the user says yes, it is going to generate a random number in the format of a die, right? If the user gives any gibberish input, it could be a mistype, it could be a wrong touch of a keyboard, right? So if any other input, it is going to issue a warning. If no, that is if n, it is going to terminate or break out of the loop. So this entire thing needs to be in a loop continuously, not an infinite loop, but a loop that can be terminated and a condition is n over here, right? So let's go ahead and... So the first important step while implementing this code would be to import the random library. So this is going to help us generate random numbers on each input, right? As we saw the implementation of the code earlier, every time we entered y, which is yes, we got a different number generated, right? So that is going to be implemented with the help of random. So it is a library in Python that generates integers or floats depending on the range that we give it, right? So we'll go ahead and look at one such implementation that is using the integer. We'll create variable I and p, which is our input, and initially we'll assign it as y. Why are we doing that? Because each time we run the code, we want at least one die roll. After that one die roll, it is up to the user that if the user wants another die roll, he can enter Y. It can be capital or small, and if the user wants to terminate the game, he or she can enter N. Again, the N can be small or capital. So let's enter the loop. We'll create a while loop and we'll give our condition till our input is either small y or our input is capital Y. So till our input is small y or capital Y, this loop is going to run, right? Once we enter the loop, we're going to create a random integer each time. So it is going to be random.randint, and we're going to specify the range 1, 6. So now what happens in this randint method is we have to assign the start and stop value, and both these values are inclusive. So we have specified 1 to 6 as our range, and in this range we are going to get a random integer each time the loop runs and we reach this statement at number 12. Okay, and then we enter our conditions. So if our num is 1, that is if the random integer generated is equal to 1, we are going to print the number 1 obviously, but now we have to create a format for our die, right? So what I'm doing here is I'm using a very basic indentation sort of format. In case of number 6, this would be our input 1. I'm going to give a space after this. So 1 space, 2 space, 3 space, 4 space, 5. So what I'm doing here is I'm going to assign 5 spaces inside the bracket so that the output looks very neat and it turns out like a die, right? And then I'm going to enter a new line and do the same thing here. But at our third space, I need a 0 instead of a space, and then I'm going to give 2 spaces again. And then I'm going to enter the new line, and then I'm going to give 5 spaces again, right? So what I've done here is I have given 4 spaces and in between there's a 0. So it turns out to be like number 0 in the center, and that's how a die is, right? And then I'm going to give the second condition, that is if num is 2, that is our random generated number is 2. So we're going to do something like this, similar. We can just copy paste it here. And since 2 doesn't look like this, rather it looks something like here, and our next 0 would be somewhere over here, right? Just make sure there are 4 spaces after you enter 0. So yeah. So this is something you can do for the rest of the integers, that is 3, 4, 5 and 6. So it would look something like this. For 3 it would be like this. And then for 4 we would have 4 zeros, 1 on each corner, right? So like this. And then we would have a number 5, 1 on each corner, and then 1 in the center as well. So that's how we differentiate. And then lastly, a number 6. There we go. So we have created a basic loop, a basic structure. So this has to be a double condition, and we were also getting an error over here. So once we resolve that, the red line is gone. Moving forward, so now we've taken our input as y initially, and since our input is y, we would definitely run this loop at least once. But now that we've run this loop once, we need to ask the user if the user wants to run this loop once again. That is, if the user wants another output of a die roll or he wants to terminate the game. So this is where we take the user input using the method input, and we give a prompt asking him roll a die ? and then we give him two options, yes or no, right? So say if the input was anything other than our yes or no, we will use the not in condition over here and we will enter a bracket statement sort of thing. So now our next condition is to check if any other input is being entered other than yes and no, right? So we'll create another if statement and we'll tell our code that if the input is not in capital Y, small n, or capital N, our code needs to issue a warning. So we will just print, say, invalid input with an exclamation mark, so that the user knows that the key he's entered is completely wrong and it does not satisfy any condition in our code as such, right? And now we can move ahead and give our other condition. So if this is not the case, if our input is somewhere in small y, small n, capital N, we can move ahead and continue with our loop. So we'll just say else continue. And then once our while loop is terminated, that means the user has entered n, right? So we are going to give our final statement, that is thanks for playing. Maybe enter a smiley emoji, right? So let's run our code. So our first randomly generated number is 5 and it's very neat. It looks like a die. And let's go ahead and enter capital Y. So it's giving 1. Let's go and do it again. 5, 6, and say I enter G by mistake. Okay, so now what's happening here is invalid input and thanks for playing. So we made an error somewhere. Okay, so if our input is not in small y, small n, capital N, we are telling the user that the input he's given is invalid, but we are not giving him another chance to correct his input, right? So we need to ask the user to give us another input since his previous input was wrong. This can be done with the help of another input method and giving a prompt roll a die ? And we'll just give a simple yes or no, right? So this is going to help the user give another input. So let's try and run again. Let me just increase my terminal size. Let me give any gibberish, invalid input, and now the program is asking us to roll a die again. So this is what we wanted. So let's give it yes this time. And it's working perfectly. Let me terminate the code. And thanks for playing. So all our 3 requirements over here have been completely satisfied and this is what we wanted, right? So now we can say that our code is running smoothly and satisfying all the conditions that were initially mentioned. So this is what a die roll code should look like and this is how it's supposed to function. So now we'll move on to our next code, that is a number guessing game, right? So let me run it. And the initial prompt is you will get 5 tries to guess the number between 0 and 100. Now let me enter any number. So I'll be smart. Since the range is 0 to 100, I will go ahead and enter 50. So now the code is telling me try a smaller number. So I will go and try 40. So he's telling try a larger number. So now I know that the number is between 40 and 50 and I still have 3 tries left. So it gets really easy for me. Let me try 45. And there, I guessed it right. So giving prompts like try a smaller number, try a larger number is really helping me as a player to guess the number right. So this is something that is changing the number guessing concept, right? So now let's go ahead and try and implement this number guessing game. We'll create a new file, call it numberguess.py. And let me just minimize my terminal. So now just like the die roll game, we will go ahead and look at the basic intent of our number guessing game, right? So again, the thing that is being repeated here is the random number that is being generated. So again, the program is going to generate a random number and the user is going to try and guess it. This is the basic concept of this number guessing game, right? So we will be using the random library to generate a random number. But this will be done once. Our user is going to get 5 tries. That means our loop is going to run 5 times, but this number is going to be fixed. This number is not going to change that every 5 times the loop runs. So this has to be somewhere outside the loop. And then our loop starts, right? So we're giving the user 5 tries. So we'll have to run a loop for 5 times. Now you can change this to 6 times, 7 times according to your idea of the game. So I did it for 5 times because I thought it was appropriate. And 5 times is something that is not too quick and not too boring at the same time. So again, it's up to you. So now our first condition would be if user guesses the number right, we terminate the loop. Right? Again, if the number is wrong, the loop is going to run for 5 times. And the next important thing we need is a function that tells the user whether the number is greater than or smaller than, right? So we need a sort of, say we need to define a function that will guide the user. Okay. Why am I saying function over here? Because we're running a loop for 5 times. So it would be better if we just call a function 5 times rather than writing that code in the loop and that loop running for 5 times and then the code executing too, right? So this might sound a little confusing right now, but as we move along, you'll understand why I'm incorporating a function rather than just writing the code inside the loop. It also makes the code look very neat, right? So first we'll import random, and then we'll go ahead and create a random integer using random.randint, and we'll give a range 0 to 100. That is what we want the user to guess between. Okay, so and then we'll print, that is we're telling the user you will get 5 tries to guess the number, which is between 0 to 100. Another important condition that we missed here was if the user guesses or gives an input or guesses a number which is outside the specified range, we need to issue a warning. Because if the user did not understand the game properly and the user is giving, say, 200 as a guess input, then there's no point in moving forward with the game, right? We will be constantly telling the user that the number is smaller and maybe the user reaches till 100 and by the time the tries will be over. So we need to design a very neat and fair game. So we're telling the user you'll get 5 tries and then we go ahead and enter a loop. So we'll use a for loop here because we know we need to run the loop only 5 times. So we'll tell the loop that the range is 5. So why am I giving 5 over here? Because we know initially if I haven't given a start value, it will be 0 by default, right? So if we go 0 to 5, I hope you guys know that 5 will not be counted. The stop value is never included. So our loop is going to run for 0, 1, 2, 3 and 4. So that is 5 tries, right? I hope that was clear. So now inside this loop, we need to ask the user to guess a value. And then after guessing that value, we need to enter another function that will tell us whether the input given by the user or the guessed value by the user is correct, is smaller than the random number generated, or is larger than the random number generated, or is outside that range, right? So first we'll go ahead and create that function. So I'll go and create a function called guess, and I will ask that user I'll call it guess int, and I'll ask the user to give me a number between 0 to 100. Or I have already specified the range over here, so I will just say enter a number. Right? So this will be my guessed int. Now that I'm asking the user to give his input inside the guess function, I can just call the guess function over here, right? And give my random number generated as an input. So now, and I need to have that as a parameter over here as well. Since I'm giving it as an argument in my guess function while calling it, I need to have it as a parameter in my function as well, right? So once I have my guessed integer, which is the input by the user, I will go ahead and start comparing. So I will say if my guess int is equal to my random integer, I will return, maybe I will return match. So it's a match, right? So if my guessed integer is maybe greater than my random integer, I'm simply going to print, say, try a smaller number. Similarly, if my guessed integer is smaller than my random integer, I will ask the user to simply guess a larger number. So these conditions are this easy, but when implemented, they really bring a really nice user experience, right? But the most important condition that we're forgetting here is the out of range one, right? So we need to implement that before we implement these. So we need to say if we need to first check that if our guessed integer is greater than 100 or our guessed integer is smaller than 0, we need to issue a warning. We need to tell that this is an invalid input, or we can say out of range input, right? And I feel this should be our first condition. This should be our starting condition, because if the input is out of range, then there's no point in going ahead and checking if it is equal to the random integer, or if it is smaller, or if it is greater, right? So we're going to keep this as a starting condition, and then we're going to check the other conditions. So if this condition fails, we will check if it is equal, and the next condition would be greater, and then the smaller one. So now this variable is going to contain the output of this function, right? So if the function is returning anything at all, it is going to be match. The only statement that it is returning is match over here. The other statements are print. So if answer is equal to match, we break out of the loop. We are not going to give the user any more tries because the user has already guessed the right answer. So we're going to break out of the loop, and what we're going to print is congratulations. But now one problem here is, what if our loop terminates on its own? What if our loop runs for the range that we have given, and the user is unable to guess in those 5 tries, and then the loop terminates naturally? It is still going to print congratulations over here, right? So we need to solve that, and to solve that we can easily create another variable called flag, and initially let's keep it 0. And once we find our answer, that means once we find that the user has given the correct input, that is our answer has matched, we will simply turn our flag to 1, and we will print this only if our flag is 1. So we're going to put this in the if condition. So we'll say if flag is 1, you print this. Sorry, it has to be a double equal to. So this is what our function should look like, and let's try running it. I hope there is no errors. Okay, so you will get 5 tries to guess the number, and the range is 0 to 100. Enter a number, let's go 50. try a larger number, maybe 75. Smaller number, let's go with 60. Larger, so it's between 60 and 75. Let's try 70. Congratulations. Okay, instead of congratulations, maybe you can print a nicer message saying congratulations, you got it right. Right? And else, if you do not get it right, the user needs to be acknowledged about that, right? The user needs to be told that you did not get it right. So maybe try again later with maybe a frown. And let's put it in quotes and let's see. Let's run it again. Maybe I'll enter a number to 100. So it's out of range. So let's go with 50. Try a larger number, maybe 70. Larger 80. Larger 90. Smaller number, so try again. So now one problem here is that the user does not know what was the right output. So maybe we can tell the user what the actual answer was. And that way the user would know how far or how close he or she was to the answer. We can say the right answer was, and we can simply print our random integer. So let's run it again. And so let me go with 50. Try a smaller number, maybe I'll go with 45, 40, 30, 20. Okay, so the right answer was 14. This is much better, right? So this was how a number guessing game was supposed to be coded, and I'm sure you guys have got it now. And you can do 100 of modifications to this code. Again, like there is no limit, right? Maybe you can go ahead and implement a GUI and make it even more interesting. So there is no endpoint for how better a code can be, how better an application can be. So it's all about how much efforts you want to put into it, and maybe even a simple number guessing game could give a really nice touch to your portfolio or maybe your resume. So yeah, that was all about number guessing game. So the next project that we're going to implement is a screen recorder. Now I know this must sound a little interesting to whoever is just beginning with Python, because this is something really intriguing as it sounds. So what the screen recorder is going to do is basically like your normal screen recording. It is going to help you screen record whatever is there on your screen, and the best part is you'll be learning about so many new things like the frame rate per second, the FPS or the resolution, and you will be working with really cool libraries like PyAuto GUI, and the other one was OpenCV. So these two are the main libraries that we'll be working with, and trust me, it's going to be really interesting. So let me go ahead to my screen recorder. And what I have done here is I have automated the entire process. So we'll be learning about it. First, we'll learn how to implement the basic screen recorder. That is, we'll go ahead and implement a basic screen recording where we'll do not have any time limit sort of thing, that we won't be automating anything, but we will just be implementing a normal screen recorder which terminates on our input, say maybe Q, right? And then later on we can modify it. We will be modifying it. We'll be learning how to implement the time and the pandas frameworks into it, and we'll create an automated sort of screen recorder which terminates in a given amount of time, right? So let me just show you guys how a screen recorder is going to work. So now the code is asking me for how long do I want to record my screen in minutes. Now I want to record it only for 30 seconds. So maybe I can give 0.5 or maybe half. So, but I won't do that. I will just say 1 minute, and it's here. So here, as you can see, my screen is being recorded. So whatever I do right now, my screen is getting recorded, and it's cool, isn't it? So this is a basic replica of my windows, and whatever's happening in my windows, it's basically an infinite loop of windows inside the windows, and you can see a smaller window over here. So this is something that we'll be implementing using OpenCV. And if I want to terminate the code, before the time, I just have to press Q. I have to have this on the screen and I have to press Q. So it's terminated, right? So this is the recording that I got. As you can see, test 1 is my screen recording file, and this is what it looks like. So it got recorded for 20 seconds. As you can see, the speed is a little faster than like, it's not the normal speed, right, of our cursor and everything. So this is again something that we'll be covering during our code. So let's go ahead and implement this. So we'll create a screen recorder.py file and let's get started. So first we'll import all our libraries, which is PyAutoGUI. So what PyAutoGUI is, it's basically a very powerful automation library, right? It basically allows to control the mouse and keyboard and even capture screenshots and perform the basic automation task required on the GUI, that is the graphic user interface, right? The next one is OpenCV, which is known as CV2, which is like the latest version of OpenCV, which was initially CV, and we're going to use it as CV. So we're going to import CV2 just as CV, so that it's just nicer to write the code with CV rather than CV2. So then our next library is NumPy. Okay, let me quickly tell you about CV2. So CV2 is OpenCV. It's basically a computer vision library. It is used for working with images, videos, the detection of features, and most importantly, implementing that drawing function. It could be drawing a dot, a line, whatever it may be, it can be done through OpenCV. So it is a very vast library and we will be just exploring a very small function in it. So our next library is NumPy, which we're importing as NP. So NumPy again is used for working with arrays. So if you guys are not already familiar with it, you will be, because this is a very common library. In almost every other code, in almost every other line, you will be using a NumPy. So let's import NumPy, and after that, we'll go ahead and import pandas as PD. So now pandas is usually used with data sets. We'll be using it over here for a very tiny functionality, which will just be converting our integer into the basic time format. I'm sure we could have done it through other ways, but this is how I prefer it. So I will just show you this one method of converting integer into the proper time format. So our next important library is time again, because initially we won't be implementing this, but later on I will show you guys how to automate your entire screen recorder process. So now the first thing we're going to do is, let me give you a basic intent for this program as well. So, okay, so let me explain you the concept of a video. So it is basically multiple screenshots or maybe multiple pictures. In case of screen recording, it is multiple screenshots, and then these screenshots are played in such a way at such a rate that they look like a video. Right, so it is like multiple screenshots being captured every second. So it is basically the FPS or the frame per second. So our basic intent is to capture screenshots and then convert those screenshots into an array format so our system can recognize them, because our system again cannot just read an image directly. It needs to be converted into something machinery. So we're going to convert that screenshot and define an FPS. We're also going to give a resolution, and the next thing that we're going to do is save that video. So if it were an image, it was very simple. It was just one line of code to save a screenshot. But in case of videos, it is quite different. We need to create a video writer object which takes parameters like FPS, resolution, a file name. It needs a file name. It needs to know where the screen recording or where that recording has to be stored, right? So this is the basic format that we're going to follow, and we're also going to come across these nice fancy terms used in photography and stuff, right? So if you're someone who's interested in this area, you're going to find this code really, really interesting. So let's get started, right? So the first thing we're going to do is define a resolution for our video. So a resolution is basically something that defines how good the quality of a video is going to be in very simple terms, right? So a resolution is basically given by the width and the height of a screen. So a resolution is basically the number of pixels, right? So we say the higher the resolution, the better the quality. High resolution means high number of pixels. So as our pixels increase, so does the quality of our image or video. So here we're not going to define the resolution by ourselves, because my system and your systems might differ. So what we're going to do here is we're going to use PyAuto GUI, and we're going to let it decide the right resolution for our system, right? So it's just going to go ahead and figure out the resolution and give it as the width and the height. So dot size, sorry, it has to be dot size, and it is going to return a width and a height tuple of the screen size in pixels. So PyAuto GUI has made our work really easy. We do not need to figure out what works for our system best. PyAuto GUI will do it for you. The next thing we're going to define is our codec. So a codec is basically a compressor or something that shrinks the media file, such as our video, in our case, our screen recording, and it will save it in our device in such a way that it is stored very efficiently. And if we were to send those files over a network such as the internet, it could be done really efficiently. So this is what codec does. It basically codes and then decodes a file from one form to another. So a codec is something really important when we're trying to save a video and then play it, right? So the format that was initially used for saving the file might not be the same format used while playing the file. So a user need not worry about it, because the codec will do it for you. So this is what a codec is. So we're going to use the video writer object over here, video writer, and we're going to implement the method for CC, and we're going to give the MJPG codec. So MJPG is basically motion JPEG. So it is a type of codec. You can learn more about it on 4cc.com. And so this is something that can be studied in real depth and real detail. But this is not the goal over here. We are going to learn how to implement a basic screen recorder. So we will not go into much detail, but you guys are free to learn as much as you want about it. So this is just a basic overview of how things work in a screen recorder, right? And then the next thing we're going to do is define an FPS. So we're going to keep it minimal. We're going to keep it around 30, so let's say 20, so that it does not give a lot of load on our system, and our screen recorder also works fine if we do not have a really high processor and stuff. The next thing we're going to define is our output. So this is where everything gets combined, and we're going to implement our video writer and pass all the necessary parameters. So the file name I want for my recording will be, let's say, test1 dot. So the name for my file would be test1.mp4, because the codec I have chosen is MJPG. If I had chosen something else, my extension name would differ, right? So my extension depends on the codec that I'm choosing, and according to MJPG, my extension should be MP4. So I hope this was clear. So I have given the file name in string format. The next thing I need to give is the 4cc, so I'll give the codec. The next thing is the FPS. It needs to be in float. It's mentioned over here. And then the frame size, which is basically our resolution. Right? So this is clear. Now we'll go ahead and create a window. Now, when I ran my code for you guys, you saw a small window over here, right? Which I moved to the left-hand side corner of my screen. Now that window is something optional, and it can be created using cv dot named window, and we're going to name the window as live because it's a live screen recording, and you can name it anything you want. And I'm just going to give it a cv dot window normal. Right now, this normal window would be the same size as my screen, so I need to resize it, and I will resize it using resize window command. And so the name is live, and my size would be somewhere around say 480 comma 270. You can play around with these values and see what fits best. So this is something I figured out after a lot of hit and tries. So now we're going to enter a loop. I will tell you why in just a few seconds. So we'll go ahead and capture a screenshot using pyAutoGUI.screenshot. And then we're going to convert this image or this frame to a NumPy array, so that our system can process it. Right? Now, why I'm doing this inside a loop is because I want a screen recording. I want multiple screenshots. I do not want just one screenshot, right? I want probably hundreds and thousands of screenshots for just 2 or 3 seconds of screen recording. So this is why I am entering this inside a loop. So my while loop is going to take care of this. And then I'll move ahead, and this frame that I converted from my image to a NumPy array, I'm going to write it in my output variable, which is my video writer. But one thing I'm missing here is a really important concept. Okay, so listen here. So when we capture a screenshot, it is stored in an RGB format, which is the red, green, and then blue. But this is common for any display application, but OpenCV especially, it requires a BGR color format to process any image or video. So what we need to do here is we need to convert our frame using cv.convertColor, and then we're going to pass our frame in one argument and tell our method that we want the color to be converted. It has to be all caps, from RGB to BGR. Simple enough. So once we have converted from RGB to BGR, we will write this image frame to our video writer, which is our output variable. And then again, we can show this frame. We can see this entire process with just one method, that is ImShow, which is basically image show. So this image is basically our one image, one frame, but we'll be capturing multiple frames, so it is going to look like a video. So it is going to be shown in that live window that we have created, and what we're going to show is our frame. So now another thing that we need to decide is how fast these frames are going to play one after the other. So this is where cv.wait key comes in the picture. Now it is going to take an argument. So we need to define an appropriate time for our cv.wait key. If this time is too less, our video will be very fast. And if this time is too high, or maybe if we define a very large number inside this parameter, our video would be too slow. So an appropriate time would be say 0.25 seconds for one frame to play after another. So we need to give a delay over here, which is 1 in our case. Again, you can go ahead and play around with it and see how the different values are going to impact your video, the quality and the frame rate, right? So now what we're doing here is we're telling if our wait key, so whenever the user enters Q on the keyboard, the video needs to terminate. So whenever there is a wait time, there's a delay of 1 and the input is Q, the video needs to terminate. So what we're going to do is we're going to break out of the loop, right? And Once we are out of the loop, we need to release all our resources that we're holding, and we need to destroy all the windows. So cv dot destroy all windows, and we're good to go, right? So let's try and run it. So there's a syntax error at line 1. Okay, so our file is running and you can see it's running successfully. So okay, so let me terminate it and let me see if, okay, so we got our test1.mp4 and we can quickly go ahead and check how it's working. So there, we're good to go, right? As you can see, the frame rate is quite high because the speed is really good. Like, our video is being played in a little bit of fast forward motion. Let's go ahead and decrease our frame rate and run it again. Let's see the output. Better, right? Now, this was a basic implementation of a screen recording. This is how a normal screen recording on your system also looks like. What we are going to do different here is we're going to implement a time strategy over here. We're going to automate the entire screen recording process using this time that we have imported. So what we're going to do here is we're going to ask the user for an input, giving a prompt. Okay, it needs to be an integer. So we're going to ask the user for how long do you want to record your screen in minutes, right? Or if we can give it as a float, we can even take say 0.5 minutes, so that would be like 30 seconds of video recording. That's possible, right? Let's give it float, and then what we need to do is convert this time into minutes so that we can integrate it in our system, right? So let's create a random variable and ask our pandas library to convert this to date time, and our parameters would be t, and our format would be a basic %n, right? So now our total time, which is the time entered by the user, is a dot minute, and our end time would be the time from now plus the total time, right? So our time now would be time dot time plus 60 into our total time. So 60 is basically the seconds, and we're converting this entire process to seconds here. So our current time would be in seconds, and when we multiply 60 into our total time, we're getting seconds again. So we are adding these two values, that is our current time and adding the total time, which is entered by the user. And for this entire duration, so what we need to do is while time dot time, so we need to run this while loop till our current time is less than our end time. So till that is the case, we're going to run this loop, and we're still going to keep this condition where if the user wants to explicitly turn off the screen recording or terminate the loop, all the user has to do is press the Q key on the keyboard, and it will terminate the loop. The other way the loop is going to get terminated is when the time exceeds or when the time limit is completed. So this is how our automation is going to work for our screen recording. Let's run and see it. So how long do I want to record my screen? Let's say 0.5, and the screen should have started. Okay. So let me run it again. Let's say 1. Okay, so now it's running and there. So it's working fine for our integer. Maybe you guys can go ahead and implement the 30-second concept in the screen recording automation and comment the solution below in the comments, right? So let me terminate this. And another thing you can do is even automate this file name and maybe even integrate a GUI so you can convert this entire code into a proper application for your system. How cool would it be to have your own application on your desktop, right? So I hope you guys have gotten a hang of it and you guys will definitely go ahead and improve this code, make it even better, implement GUI using tkinter. Tkinter is something that we'll be looking at in our coming code, so need not worry about that. But yes, do implement the GUI concept and try and make this code even better. So now our next project is round robin algorithm. Now, in order to understand round robin algorithm, first let's understand what it is. So basically, round robin algorithm is again a CPU scheduling algorithm which focuses on time sharing concept. So now if we have multiple processes, so now this round robin algorithm is going to facilitate a sort of a method where no process has to wait for a very long period of time. So now we have implemented a very basic round robin algorithm where we consider the arrival time to be the same. That is, we are considering that all the processes have arrived at the same time and there is no conflict of arrival time over here. So we are not going into that detail, but through this algorithm, we're going to mainly focus on the data structure aspect of Python, right? So let me quickly show you how our program is going to be implemented, how it's going to work, what is the basic functionality of our project. So once I run it, it is going to ask us to enter the number of processes, which is basically how many number of processes are to be scheduled at a particular time, right, for the CPU. So let's say I want 3 processes to be scheduled. Now the next prompt is enter the time quantum. Now the time quantum is basically the window or the time range which is going to define for how long each process is going to run as soon as it is out of the ready queue and it is running, right? So let me give the time quantum as 2. So now the next prompt is enter the arrival time and burst time for process 1. So our arrival time is going to be 0 and let's say the burst time is 10. And then similarly, we're going to give the arrival time as 0 and burst time is 5 for process 2 and burst time as 8 for process 3. So our algorithm has simply calculated the waiting time, the average waiting time and the average turnaround time for these 3 processes. Now, in order to understand the code or the implementation behind this logic, first we need to understand the round robin algorithm, the working in detail. So in order to do that, I'm going to quickly take you to this website. You can check it out through this link. And what I have done here is I have taken only 4 processes and I have defined a time quantum as 30 because our burst time is really huge over here. You can see the burst time is 80, 60, 65 and 120 and the arrival times. Okay, let me take the arrival times as 0 for all the processes. So you can edit. So this is how you can edit your processes according to the calculations that you need to check or the visualization you need to check, right? So I'm going to go ahead and visualize it. I have to select round robin over here. So you can see all the 4 processes are in the ready queue at once and the order keeps changing as one process runs and the other is still waiting, right? So now there are only 3 because one has completed, it has ended. The rest 3 are running and now you can see we have only 2 processes and then lastly we have P4 because as you can see it has the maximum burst time over here, so naturally it's going to run till the end. So this was just a basic visualization, but in order to understand it I have taken another example for you guys. Okay, so as you can see I have taken 3 processes over here. P1 with arrival time 0, burst time 10, P2 with arrival time 0 and burst time 5 and P3 with arrival time 0 and burst time 8, right? So this is also the algorithm that we passed in our code, right? So now what's going to happen is, so in order to calculate the completion time and the turnaround time and the waiting time for each process, first we need to find out how the processes are going to be scheduled in a round robin algorithm, right? So first let's start with P1. So we're going to have P1 over here as our starting process. So since all the processes arrive at the same time, that is arrival time is 0 for all the processes, we can start with the process on the top, right? So we'll start with P1. Let's say P1 enters over here. This is a sort of Gantt chart. So with the help of this chart, this Gantt chart sort of diagram, we're going to calculate the different time constants for each process. And in the end, those time constants are going to help us calculate the average waiting time and the average turnaround time. We're also going to look at what these waiting time and these turnaround time mean, right? Once process 1 enters, so let's say this entered at time 0, and since our time quantum is defined as 2, it is going to run for 2 hours, you can say, or 2 minutes, whatever the unit is for the time. So once it does that, so initially the burst time was 10, so now it becomes 8 for P1. And since P1 is running, in the ready queue we have P2 and P3, right? So they are waiting for their turn after P1. So once P1 is done running, we'll have P2 in the next window, and it will again run for 2 time quantum, and we'll have P3 and then P1 in this particular order waiting in the ready queue. So P2 was 5. After running for the particular window frame, it is going to be 3, right? Then next we have P3, and it is again going to run for this particular time, and we'll have P1 and P2 in the ready queue. So P3 was 8 and then it becomes 6. Similarly, we're going to repeat the process until all our processes end, that is, they complete their execution. So we're going to have P2 and P3 in the ready queue waiting for their turn. P1 was 8, then it becomes 6. Then we'll have P2 again running for 2 time quantums, and we're going to have P3 and P1 in the ready queue. P2 was 3 and then it becomes 1. Then after P2 we're going to have P3, and it is again going to run for 2 time quantums. P3 was 6, it becomes 4, and we'll have P1 and P2 in the waiting queue. Then we'll have P1 running, and it'll run for 2 time quantums. P1 was 6, so it becomes 4, and we'll have P2 and P3 in the ready queue. Then we'll run P2. So now P2 over here had only 1 burst time left, right? So it will not run for 2 time quantums. It will reduce its window to 1 and complete its execution in that particular window itself. So now since the execution is completed, it will not be going back into the ready queue again. Rather, we will just have P3 and P1. And since this process is completed its execution, it will be ended over here itself. Then we'll just have P3 and P1 left for execution. So P3, it was 4 before this, and it will become 2. So it will run for 2 time quantums. Then we'll have P1, which was 4, and it becomes 2 now. It ran for the window 17 to 19. Then we'll have P3, and then we'll have P1. P3 ends over here because it was 2, and then P1 ends over here. So basically our processes will end at 21 and then 23. So the total time taken by the 3 processes is 23, because as you can see over here, at 23 all the 3 processes end their execution. They have completed their processes, right? So now our next agenda is to basically calculate the completion time, the turnaround time, and the waiting time for each process that we have in our scheduling algorithm, right? So let's understand what these are. So completion time is basically the time at which the process completes. Now completes as in completes is execution fully, right? It ends where the process ends, where we have cancelled the process. That is the time where it has been completed. So completion time can be easily calculated as you can see over here. So P2 completes at 15, P3 completes at 21, and P1 completes at 23. So that is really easy to calculate. We can just fill it up over here. P1 completes at 23, P2 completes at 15, and P3 completes at 21. So once we have our completion time, the next thing we need to calculate is turnaround time. So now turnaround time is nothing but completion time minus the arrival time. So again, this is really easy to calculate. So we have our completion time over here and we have our arrival time over here. Since our arrival time is 0 for all three processes, our turnaround time is going to be the same as completion time. So we just have to fill it up like this, and 21. And now our last constraint is waiting time. So now waiting time is nothing but turnaround time minus the burst time. So our turnaround time is over here and our burst time is over here. So using these two columns, we can calculate our waiting time. So 23 minus 10 is 13, 15 minus 5 is 10, and 21 minus 8 is 13 again. Right, so I hope this was clear. I hope you guys found the round robin algorithm working really easy. So this is basically the final table that we need. So now in order to calculate the average waiting time and the average turnaround time, all we need to do is add these three values for waiting time and these three values for the turnaround time, and then divide them by the total number of processes, which is 3 in our case. So that will give us the average waiting time and the average turnaround time. So let's go ahead and calculate it. So average waiting time is equal to 13 plus 10 plus 13, which is divided by 3, which is nothing but 36 divided by 3, and it is equal to 12. Right? Similarly, we can calculate the average turnaround time, which is nothing but 23 plus 15 plus 21 divided by 3, which is nothing but equal to 59 divided by 3, which is equal to again 19.67. Right? So this is how the basic round robin algorithm functions. So now we can go ahead and look at the working of our algorithm in our VS Code, right? So now that you have gotten a basic understanding of the working of round robin algorithm and the logic behind it, we can go ahead and implement a code in Python. So the first thing that we got as a prompt when we ran our program was the number of processes that were required in order to schedule the algorithm, right? So we're going to take that input as well, the first thing. So we'll take the input and we'll give the prompt, enter the number of processes with a colon, and we'll give a space so that it looks neat, right? And we'll also define a quantum, and we'll take the input from the user and give the prompt saying enter the time quantum, right? Now we need to create some variables that will help us store the information about the process, the arrival time, the burst time. And then we also need to create some variables that will help us store the calculations that will be happening in our algorithm. So the first variable I'm creating is the time. So this variable is going to help me keep track of the time as I'm moving forward with the processes. So the next variable I'm going to create is processes, which is a list, and it will be storing all the details about all the processes that the user is going to enter. So the details for these processes will be taking using a for loop. We're going to run a loop for a range, which is n, where n is basically the total number of processes that the user wants. So we run a for loop for n times, and then we print, that is, we tell the user to enter the arrival time and the burst time for process I plus 1. Since our range is going to be from 0 to n minus 1, we need to give the input as I plus 1 so that it is not process 0, rather it is process 1. So it is going to make our code look neater and more clear for the user to operate with it. And then we take the input so that the user can enter the input using a space. We're just going to use the map function and we're going to take it as a list, and we're going to give integer. And so now we're going to tell the program to split the input. So since we're not giving any parameters over here, we're supposed to split on the basis of the space. So wherever there's space, it will be splitted. So our input variable is basically going to be a list containing the arrival time at index 0 and the burst time at index 1. So let me just comment it for you guys. It is basically going to look like this. Say arrival time is 0 and the burst time is 10. So our input is going to look like this, right? So the next thing we need is we need to have different variables like the arrival time, the burst time, and we need to create another variable which is the remaining time, and we're going to assign these variables as arrival time is at index 0 and our burst time is at index 1, and the remaining time is initially the total burst time of the process, right? So remaining time is going to keep track of how much time the process has left to complete its execution. So initially the remaining time is going to be the same as burst time, so we're going to assign input at index 1 to remaining time as well. And then we're going to store all this information in our processes variable which we have created before beginning the loop. So we're going to simply say processes.append, and we're going to store this in another list, our arrival time, our burst time, and our remaining time. And we're also going to pass a fourth element over here, which is 0. So this is going to act as a flag. So for each loop, for each process, we are going to calculate the waiting time. So in order to know that the waiting time for a process has already been calculated or not, we're going to keep track of it using a flag. So initially a flag is going to be 0. And as soon as we have calculated the waiting time for a process, this flag is going to turn as 1. So this is how we know that we have already calculated the waiting time for a process and it need not be calculated again. So this is how we're going to get an accurate result. And then we're going to assign the total time as the burst time of all the processes. So when we run a loop, we can define the condition as till the total time is not 0, the loop has to run, right? So do not worry, as we go through the code, you will be able to understand it. So we need to create a variable over here, total time, which is initially 0, and then later on we'll keep adding the burst time to it. So by the end of the loop, the total time is going to be the sum of all the burst times of our processes, right? Now in order to calculate the waiting time, we also need to have a variable wait time, which is going to be a list because it is going to store the wait time for each process, right? So the next variable we're going to have is total turnaround time, and again it is going to be a list because this is going to be again calculated for each process. And then we go ahead and run our while loop. So we say while total time is greater than 0, we need to run this loop. So since we're giving this condition, at the end of each loop, we need to subtract this total time with the time of each process that is being completed, or the quantum, right? So let's go ahead and look at that logic as well. So we'll go ahead and run a for loop inside this for our each process. So we're going to say length of our process so that our each process is run. So our first condition is till our total time is greater than 0. That is our first condition. And then what we're doing is we're going to access our each process that is stored in the processes variable. So we're going to access each process one by one using this for loop, and we're going to repeat this process until the total time is greater than 0. So this is the basic strategy that we are following while implementing these loops. So as soon as our process enters this loop, we need to check whether the remaining time is greater than our quantum. So our quantum is 2. So when we saw the implementation of our algorithm and we calculated the waiting time for each process and the completion time, in the Gantt chart we saw that whenever the remaining time, that is the leftover burst time for each process, was lesser than the quantum, we wouldn't run that process for the entire quantum. Rather, we would just run it for the remaining time that the process had left. Right? So when we saw in the case of process 3, the remaining burst time of the process was less than a quantum, which was 2. So we just ran it for that one quantum rather than the entire time quantum that was defined, which was 2. So that's the first condition that we're going to check. So we're going to say if the remaining time, now the remaining time for a process is stored at process I and at index 2. As you can see, our remaining time over here is at index 2, 0, 1 and 2. So we're going to access the remaining time and we're going to check if the remaining time is greater than our quantum. We're going to run it regularly. That is, we're going to keep track of our time here as well. So we're going to increase the time by the quantum, and then we're going to decrease our total time by the quantum. We're subtracting the quantum from our total time, and we'll also decrease the remaining time of the process. That is, I'll just copy this over here. We'll also decrease this by the defined quantum that was passed by the user itself. So our next condition is to check whether the flag, that is the waiting time of a process, has been calculated or not. So what we're doing here is basically we're creating a first condition, which is checking if the remaining time of a process is greater than a time quantum or not. So if the process's remaining time is greater than the time quantum, we simply go ahead and reduce our total time by the quantum, and we decrease the remaining time by the quantum. Now, if this is not the case, if our process has remaining time which is lesser than the time quantum, then what needs to be done? So basically, say a time quantum is 2 and the remaining time of a process is 1. So in this case, this process has to have its last execution, because the remaining time of the process is less than the time quantum defined. So definitely in this last execution, the process should complete its execution. So if the process's execution is also completed, the waiting time should be calculated in this loop itself, right? In this iteration itself. So this is why we're giving the second condition. If the first condition is not met, that is, if the process does not have its remaining time greater than the time quantum, it needs to terminate in this iteration itself. So what we're doing here is we're going to increase the time by the remaining time of the process. So now we're going to calculate our waiting time over here, because this is where the process completes, right? So now we know waiting time was equal to turnaround time minus burst time, right? So we've already seen in the working of our algorithm that whenever our arrival times are going to be 0, our turnaround time and our completion time is going to be the same. So turnaround time is basically completion time minus the arrival time. Since all our arrival times are 0, so our turnaround time is going to be equal to our completion time, right? So in that case, we are going to simply give waiting time is equal to completion time minus burst time. Since our arrival time is equal to 0, our turnaround time is equal to completion time. So now a completion time is basically calculated with this variable over here. This is the total time that a process took to complete its execution, right? So we can simply say time minus burst time. So this is how our waiting time has been calculated. Now all we have to do is we need to update the flag for this process. Let me just copy paste. and we're going to update it to 1 so that our algorithm knows that the waiting time has been calculated for this process and it does not enter this condition again, right? So now why this condition is very essential over here is because even when the process has completed its execution, because of this for loop, this process is going to be considered again, right? It is once you consider the dry run of this program, you will understand that all the programs are going to be accessed, are going to be checked for this condition, for the first condition and the second condition again and again, until all the processes have completed the execution, or until the total time is not greater than 0, it is equal to 0, right? So we need to define this condition very crucially, because if we do not do this, the waiting time for that process is going to be calculated again and again until all the processes have been terminated or have ended. So we update the flag for this process that the waiting time has been calculated and it does not need to be calculated again. So do not let that process enter this condition again. So once we update the flag, we also need to update the remaining time of the process, which is at index 2. And we're going to say that the remaining time of the process is 0 now, because the process has been completed, it has been terminated, right? And then we also need to calculate the turnaround time. So in order to calculate the total turnaround time, we can just append the time. So in order to calculate the total turnaround time, we can just append the time at which our process completed, right? Since our arrival time is same and it is 0, so our turnaround time is going to be the same as completion time. All right. So now that we have calculated our waiting time and our total turnaround time, we can exit the loop, and all we have to do is we have to print the average of our waiting time and our total turnaround time. So let's enter a new line, and average waiting time is, and so all we have to do is calculate the sum of the waiting time, which is basically a list, and we can just pass the method sum, and in the parameter we've passed the waiting time and we have divided it by the total number of processes. Similarly, we're going to calculate the total turnaround time. So we're going to say average turnaround time is equal to, and similarly we're going to calculate the sum of the total turnaround time and divide it by the total number of processes. Alright, so let's run it and let's see if it's working fine. So my process is going to be 3, time quantum is 2, arrival time 0 and 10, 0 and 5, 0 and 8. Okay, and I am not subtracting the total time over here. So again, the loop is not terminating and it has probably gone in an infinite loop. So I need to end this and run it again. So what I missed here is I need to subtract the total time by the remaining time of the process. So let's run it now. So 3, 2, 0 and 10, 0 and 8, sorry 0 and 5 and 0 and 8. So there, our average waiting time is 11.6, which we can consider as 12, and our average turnaround time is 19.67, we can say. So this is all about round robin. I hope you have got a basic idea about this project and you guys will definitely go ahead and implement it. And you guys can even go ahead and modify the arrival time to calculate the processes that arrive at different arrival times, right? It is just going to change a little bit of logic that we have implemented over here. The rest is going to be the same. So I want you guys to try it out and tell me in the comments about it. So let's move on to our next project. So now our last project is basically the to-do list that we have implemented. So now what I have done for my to-do list is I've gone ahead and built an executable file for my to-do application, and I do not need to run any code in order to run my application. I can just do it through this executable file. So this is what it's going to look like. So I can enter my task. It could be, say, Python, and I submit it. And you can see my first task of the day is Python, and maybe my second task could be, say, lead code. Maybe I want to practice lead code, so I just say lead code. Now, another functionality of my to-do list is the task number that I want to be deleted. I can just enter over here. So say I want the task number 1 to be deleted. I enter 1 and I click on delete, and my first task is gone, and which was previously my second task, lead code, is now my first task. So again, this is a very simple logic that we'll be implementing, and if I want to close the app, I can simply click on exit app, or I can cross from here. So I'll just click on exit app, and there. So this is what my application is going to look like, and I am going to show you how to build it. So now let me quickly tell you about this to-do application. So I have used Tkinter for the GUI. Whatever you saw in that box when I ran the application was built using Tkinter, so it is not that difficult. I'm sure you guys will be easily able to implement this. So what I have done is I have imported my Tkinter. I have imported all the libraries that are needed from Tkinter, and I have imported the message box, which is going to be used quite a lot. So the next important thing that you need to keep in mind is I've created tasks and my counter variable as a global variable. That is, I'm not creating it inside any function, rather I'm creating it globally so that it is accessible to all my functions that I'll be creating in future, right? So my task is a list. This list is basically going to store everything that I will be entering in my input field, and which will be displayed in the text box area that you could see with those bullet points in the numbers, right? And my next important variable is the counter. So this counter is initially 1. So it is going to keep track of all my lists, the number of lists, the number of items I have in my to-do list, right? So this is not something I'm going to cover in detail. So this here is basically the Tkinter implementation. What all you have to do is, so I've created a main class over here, and then I have created my root. So the window that I have created using Tkinter, I have stored it in the variable root, and I have configured the background as light pink. You can choose your own color. I have titled it as to-do app, and I've given it a geometry. I didn't want the app to be too big, so I created a nice 250 by 300 dimension application. And then what I'm doing is I'm creating a label that is enter your task, and I have positioned it at row 0 and column 2. So again, this is something that you can experiment with. So I have created a task field that is going to take input for my task entry. I've created a submit button. Then I've created a text area. So this text area is basically going to display all my list items that I have inputted in my to-do list. Then I have created a task to delete field. So this task to delete variable is basically going to take the number of the task that the user wants to be deleted, right? And then I have positioned it again using the grid method. And then I have created another task to delete field. Now this is going to take the input. This was the label, and this is going to take the input. As you can see, text and label over here. And then we have the next variable, which is delete. So this is again my delete button. When I click on it, as you can see, the command is delete. So whenever I click on it, my function delete is going to be activated, which I'll be taking you through in the next few seconds. And then my last functionality is the exit button, because when I click on it, my application will be exited. That is, it will be closed. And then in the end, I have the main loop, using which the entire process is displayed on the screen. So let me quickly take you through the functions. So my first function is clear the task number field. So the task to be deleted. So now the first action button is my submit button. So whenever I enter any item in the field that I want to be displayed as my to-do list item, I click on the submit button, which basically acts on this command, which is insert task. Now let's go ahead and look at my insert task function. So my global variable is counter over here. and what I've done is value equal to input error. Now, if somebody does not give any input and just directly clicks on the submit button, what it's going to do is it's going to display an error message, which is going to say input error. So you basically cannot allow any user to give an empty input, right? So you need to check if the input field is empty, you need to return 0. If that is not the case, we'll return 1. And similarly, if we're checking if the value is 0, then we'll just return. Right, we are not going to execute any further, we're just going to return from this task, insert task function, right? But if the value is 1, then we'll go ahead and perform these operations, which is basically we're going to fetch the input that the user has entered using the get method, and then we'll append that particular item through the variable entry. We'll append it to our task, that is our global variable again, which is a list. So we'll append that item to our list, and then in the text area we'll insert it using n-1 characters. So n-1 characters is basically the position at which the text area is going to store this particular or display this particular entry, right? And then we're creating a bullet over here, which is we're converting the counter variable into a string and we're appending it over here, and then we're displaying our entry as one single string, right? So we define the position where we want to display it. So we want to display this at the end, and we want to go -1 position. That is, we want to go -1 because our index starts from 0, and we do not want to start at the last index. Rather, we want to start at -1 index. That is, we want to start at 0, not 1, right? And then we increase our counter. So since we are appending one item to the list, that is our task list, we are going to increase the counter by 1. So initially it was 1 and now it has become 2. And then we clear the task field, that is, we clear the input field. Let me just quickly show you the application once again. So as you can see, once we enter any item, we click on submit, this field is cleared up. So if I try and enter the empty field, it is going to give an input error over here, as you can see, right? So this is how our application is functioning. So in order to clear this field, I have created another function, clear task field, which basically, as you can see, it's implemented over here. So it is going to create the entire field, the entire entry. So that is why we need to pass 0 and end over here as the parameters, and it is going to clear our field, right? So the insert task function is clear. Now the next command or the next action that we are going to perform is delete, right? As you can see over here, if I want to delete this particular item, I just have to enter 1 and click on delete. If I click on delete without having any entry over here, it is again showing an error message, that is no tasks. So now let's go ahead and look at the delete function that we've implemented here. So again, we've created a global counter which is going to consider counter globally, that is, it is going to consider the changes made over here and over here. So as soon as the user clicks on the delete button, the first thing we're checking is if we do not have any tasks in our task list, it is going to show an error, no task, right? So it is going to return automatically, because if there's nothing there to delete, what is it going to delete, right? So the next thing we're doing is we're fetching the field entry or the number the user has entered for which the task has to be deleted, right? So in order to get it in integer format, we're going to pass 1.0, and we're fetching the entry or the number inputted by the user and storing it in num. So now we're checking if num is empty, that is, if the user has not inputted anything and directly clicked on delete, it is again going to show an error message which is invalid input, and it is going to return from the function. But if that is not the case, we're going to convert this num to an integer format and we're going to store it in task number, right? And then we have to clear this field as well, just like we did it for the input field. We're going to clear it for the task number field as well, and we're going to do it through 0.0, right? And then we're going to delete that task using the pop method from the list first, and we are going to pass the task number minus 1, because when we are giving the task number, which is the bullet number, it is string plus 1. As you can see over here, our counter is starting from 1, not 0. So when you're giving the index number, it has to be subtracted by 1 so that the correct index is being passed. And then we decrease the counter by 1, and then we delete it from the text area as well. And when we delete any item from our list over here, say we have 3 items and we delete the second one, the third item needs to be shifted to the second position. So in order to rearrange the numbering, what we do is we delete the entire text area and we recreate it using a for loop, and we insert at the end, we insert each bullet point. As you can see, it is I plus 1 and then the task at I. So this is how it is recreated, and I hope you guys got a hang of this to do application. You guys need not worry about the GUI part of this application, but with the main focus should be the logic behind it, why we have performed operations like subtracting 1 from the counter when we're deleting an item, and why we have increased the counter, why we've used global as the keyword before our counter. Understanding small things like this is going to get you really far. So focus on the basic concepts rather than the GUI part. And I hope you guys got a basic understanding of this algorithm. And trust me, if you guys really work on a project, that is, if you guys do not keep it very basic, very fundamental, and rather implement something of your own, implement your own creative ideas to the project, it can totally stand out of the other resumes, and it will definitely hold some value when you're entering any interview, or even if it's a class project, right? So implementing your own ideas to a project is what really matters. So this video, the main aim was to help you build a basic logic and a basic understanding of how to go about things, right? And I hope you guys are further going to implement them and improve them. And if you guys like this video, do hit the like button and do not forget to subscribe to the YouTube channel. Thank you and see you in the next video.